This is what math can tell us about the past.
Radiometric dating is a way to determine a fossil's approximate age by using the ratio of certain elements and their half-lives. There are several different types of radiometric dating, and they each have their own applications. One of the most common methods is carbon dating. Here's how it works. While organisms are alive, they absorb radioactive carbon-14 isotopes through their food and the CO2 in the air. When they die, they stop absorbing carbon-14, and what's left in their tissues and bones starts to slowly decay. The rate of this decay is very predictable and is called a half-life. The half-life measures the amount of time for half of the carbon-14s to decay, which is approximately 5,700 years. Carbon-12, on the other hand, is not radioactive and does not decay. Scientists can compare the ratio of carbon-12s to carbon-14s to calculate how long since the organism died.
A restriction to this type of dating is that it only works on organisms that died in the past 60,000 years. To date dinosaur fossils, scientists must examine elements with longer half-lives. Uranium, for example, has a half-life of approximately 4.5 billion years. Uranium, however, isn't found in organisms, so scientists must date the rock layers around the fossils rather than the bones themselves. Here's how this works. After thousands of years, carbon-14 has completely decayed, leaving carbon dating useless. Scientists rely on the uranium and igneous rock layers to determine the approximate age of fossils. They measure the ratio of uranium-238 to lead-206 and use the half-life equation of uranium for radiometric dating. The layer beneath the bones is dated to determine the upper bound of the fossil's age, and the layer above tells us the lower bound. This method of radiometric dating gives us a range of the fossil's age.
Radiometric dating allows us to look into the past and unlock truths about the Earth and the history of life itself. It is remarkable that math and science can tell us so much about what happened millions of years before the first humans existed. These dating techniques can be used to construct a clearer and more accurate timeline of the evolution of life on Earth. For example, we can use radiometric dating to determine which species were alive at the same time and when mass extinctions occurred.
This information shows us how organisms would have interacted and helps us reconstruct a prehistoric food web. We can also see how the Earth's environment changed over time by dating rock layers. For example, by dating different layers, we can approximate how long various habitats of the prehistoric world lasted, such as ice ages, deserts, and grasslands. With half-lives, we are able to construct the past, a world we've never seen before, and learn about the behaviors of organisms that walked the Earth before us, as well as their diverse environments.
Thanks for listening.